Hi, everybody, and welcome to section 2.2, which focuses on histograms, frequency polygons, and time series graphs. So let's begin. You ready? Okay, guided notes out or not guided notes out. Not sure what kind of a learner you are, so let's go. Okay, histogram. A histogram, it looks similar to a bar graph, except that the histogram consists of boxes that touch. They're joining. They're next to each other. It has horizontal and vertical. So horizontal is usually what the data represents, and the vertical axis is either frequency or relative frequency, or probability of happening or percentage. Then the graph has the same shape, and then either way. What's cool about the histogram, it can give you the shape of the data, the center, and the spread of the data. Okay, so we often use histograms when we have a data set of 100 or more. So how do we conduct a histogram? So first of all, we need to decide how many bars or intervals called classes represent the data. So many histograms consist of 5 to 15 bars. Okay, so we need to first choose, okay, I'm going to have this have 5 bars or 10 bars, and then we need to choose a starting point for the first interval that's less than the smallest data value. Okay, so so usually a convenient starting point is something that it's either a lower value carried out to one more decimal place than the value with the most decimal places. That sounds confusing, so let's look at an example. Okay, so for example, let's say you have 6.1, right, in your data set. And if that was the smallest value, then a good starting point is you would subtract a two decimal, right? So that way you can have something that's 6.05. You could have it that's directly underneath 6.1. So if you have, let's say the value with the most decimal places is 2.23, so you have 2 decimal places, but yet the lowest value in your data set is 1.5, you would subtract something that gives it 3 decimal places. In other words, 0.005 is a good example. Okay, so forth. So if it was whole integers, and then a good starting point would just be, 0.5 underneath whatever the lowest value. So in this case, the lowest value is 2, and you have here, you would subtract 0.5 and then get 1.5. So, all right, why do we even do that? Like, who cares? Who cares? The reason that we do that is because this way you construct your histogram in such a way that no data value falls on a boundary. So it's kind of like you're building a fence, for the data, like a little corral, if you will, and you don't want to build the fence on top of the dog, or whatever it is that you're trying to corral. I don't know, dog, sheep, I don't know, city person. Anyway, you guys get what I'm saying. So let's continue. So let's say here we have a bunch of data. I'm not going to read this data because it's 100 values, but they are the heights of male semi-professional soccer players. So they're in inches, okay? So heights is continuous since height is measured, right? Remember that from chapter 1. So then the smallest data value in this is 60. So like so the data with the most decimal places has 1 decimal. So like for example 61.5, we want our starting point to have 2 decimal places. So we subtract 0.005, which has 2 decimal places, and so our starting point will be 59.95, which is more precise than, say, 61.5 by 1 decimal place. So we start there. Okay, and that's the data again. And let's see here, how do we find the width of each bar or class interval? So since it was, the height, where does this come from? This here, this here is 2 decimal places above the highest one. So the largest value was 74, so we add 0.05 to 74. Okay, so that's basically you've fenced in your data. You have the lower fence and the upper fence. So in order to find out your intervals, let's say we wanted to have 8 bars, we subtract the difference, which is basically the distance covered, and divide by 8, which is 1.76. Okay, so this is just a good place to find out the width, okay? So how wide you want each bar to be? Approximately 1.76. The thing about this is you usually just round up to an integer because it's easier. It's really hard to add 1.76 and then add 1.76 and then add 1. I mean, we could do it, but it's just not as it's not as nice as 2. Okay, so then here we go. So here I start at 59.95. That was my starting point. Remember, we subtracted 0.05 from the lowest, which is 60, so that makes us 69.5. Then we decided, oh, our intervals are going to be 2, so we add 2. We get the next place to plot. Then we add 2, 63.95, add 2, 65.95, add 2, add 2, add 2, add 2, and then finally add 2. So that's basically it right here. And then that's where you draw your histogram. So this here is the relative frequency of each one, meaning that 5% of the data is between 59.95 and 61.95. Okay, so let's think about that. So 5%. So that means 5 numbers need to be within this range. So you have 60, 60.5, 61, 61, 61.5. Exactly 5 numbers, so 5%, right? And then how many fall in this data? Well, this is 3%, so there should be 3 of these, right? 63.5, 63.5, 63.5, and there's the 3, and so forth. You could test this, okay? So go ahead and test that and make sure that, the data falls within the range specified. But see how it's all bars connected? This is our histogram right here. It looks like that guy. All right. So, of course, just heads up, like in this course, we'll talk about a way to do something that's kind of really complicated, and then I'll show you how to use it on your calculator, and you're going to be like, what? Why didn't you do this initially? That's just kind of how it goes. Okay, so just expect it. It's like, I don't know. Okay, so here we have the following data, right? So let's say we have the number of books bought by 50 college students. So here's the books. We have this many 1s, this many 2s, this many 3s, this many 4s, this many 5s, and we have 2 6s. Okay, so we're going to plot it into L1 and L2, and this is going to be the data value, which is 1 through 6, and the number of times that it occurs. So, 11, 10, 16 times, 6 times, 5 times, and 2 times. Okay, so that's the first thing I'm going to show you, and it's on the next slide right here. So first we hit y equals, and then we hit clear. We hit stat1 edit, so stat edit, and if you have L1, like you need to go into the name L1 and press clear, but if not, you enter 1, 2, 3, 4, 5, 6, and then L2, we do the same thing. If it has data, then let's press clear and then arrow down, and if not, then we just hit L2, enter the data here. This is the frequency. List 2 is the frequency of 1. So 1 occurs 11 times, 2 occurs 10 times, 3 occurs 16 times, right? 4 occurs 6 times, 5 times, and 6 is 2. Okay, so that's that. So then here are some guides for your window. So you can use these. Or you can do zoom stat on your calculator. Okay, and I'll gladly show you this during section, like during our Zoom times. Okay, so here we hit y equals, and then you go plots off, and then when you hit plot 1, you have to do this type. It shows you, so you go to enter type, and then you go to the picture, which is histogram, and you hit enter. And then where you say X list, you have to hit L1, which is same as hitting the second key and then 1. And then same thing here. And you hit graph, and you're going to see a beautiful graph that was on the previous page. All right, so that's histograms. Next, we have frequency polygons. So what the heck is a frequency polygon, and why do I care? Well, let me just tell you why. So frequency polygons are similar to, remember we did line graphs, but they're different. Okay, so don't jump to conclusions. Oh yeah, they're just line graphs that I connect to the bottom. No, they're not. Okay, so how do we do it? We do a frequency polygon as if we were graphing a histogram. So we already know, like 10 minutes ago, you went through and we created a histogram together. So suppose you did that, but instead of doing the bars, you hit the midpoints of the intervals on the x-axis. So basically, if you take a histogram and draw a dot in the middle of each bar, and connected those dots, and then connect, put a dot at 0 and then a dot before and after, half, one interval below that, then you would get a polygon. So let me show you a picture. Okay. So here it is. We have this is the example that we did before, right? And let me show you. I'm just going to try it. Okay, so if we did a histogram for this information, it would be like the bar is, oops, you get it, oh shoot. It's here, then it would be up here, right? Because the dots are in the middle of the bar that belongs to the histogram. So that's why you use the same data, but except now you see you're putting a dot instead of the top of the bar. Okay, so this one was probably like up here, something like this. You know, if I was to do a histogram, so this is how they're related. Okay. I'm really sorry that it looks crazy, but I think from here you guys could see what I'm talking about, right? Okay, so that's it for frequency polygons, and we will probably never ever see it again. Okay, this next example is something that you've probably seen in a high school exit exam or some kind of class where they give you like a little story at a table and a graph, and then you have to be able to identify a point on the graph and tell the X or Y axis. So that's kind of what that is. I don't know if you guys remember that. Maybe you've blocked it out. But basically, you have a regular coordinate system, and you have X and Y. X is usually the date or time, and vertical is used to plot the value of the variable. So we're basically talking about time, okay? So here is an example. So we have a table. This is like the United States in these years emitted this much carbon dioxide. That's a lot. And then if we did this and we did a nice little line graph, right? It's like this, okay? And pretty much that's the time series graph. We have our time, and then we have what we're measuring, which is CO2 in millions. And you just plot these points and connect the dots. So that's a time series graph. All right, so that is it. Yay, for 2.2. And this is your super fun homework. Now notice, yes, this is not an odd. Number 12 is not an odd. So if you want to double check your answer, please send me an email, and I will let you know if you were right or wrong. Yes, but you'll understand why I make you do this one, because you would need to do it anyway. Okay, guys, see you in the next video.